Electricity generation with offshore renewable technologies has many advantages. Large areas and various energy sources are available at sea, and higher and more constant wind speeds mean that an offshore wind farm generates energy more regularly and reliably than a farm on land. While contributing to our climate goals, renewable energy generation, as well as other economic sectors, such as shipping and fishing, are putting pressure on the marine ecosystems, whose ecological state is already degraded. Seas not only serve as a habitat for countless animals and plants, but also as the biggest natural CO2 sink.
So the wind farm itself is 165 turbines, which is pretty spectacular.
Now that's nearly 500 turbine blades, these 81-metre long blades.
This is one of the 81-metre blades that we used in Hornsea 2. 495 blades in total, they're all up in the North Sea.
All of them produced here, locally, in Hull.
It's about 90 kilometres off the Yorkshire coast. It covers an area of about 500 square kilometres, so it's a real large site.
Blundell Park is a local football ground in Grimsby. To give you a sense of the scale of Hornsea 2, it would take 66,000 Blundell Parks to create an area large enough for this wind farm.
We're now at the Humberside offices for the Hornsea 2 project. Behind us is the helicopter terminal.
We've had more than 6,000 people transfer in and out of this wind farm. So there's a fleet of vessels, an army of people.
Every time we sailed, there were 4,000 tonnes of turbine components on the vessel.
It's quite a well-rehearsed routine now that we've got going here. It's been optimised over the years. 3 blades per turbine, 4 towers and then 4 nacelles.
We had people working on Hornsea 2 all over the world, and in particular we had thousands of people out in Singapore and Indonesia working on our offshore substation and reactive compensation station.
So it was the Sleipnir that lifted the substation into its final location. It's probably one of the only vessels in the world that can actually do that.
45 vessels in total, which is 4 more than the entire Portuguese Navy.
To spend nearly 2 years preparing to see it operational now and turbines being handed over to us in operations and maintenance is absolutely brilliant.
We have not only been able to deliver this amazing project, but we've also been able to keep our people safe. Hornsea 2 has been delivered with absolutely no lost time incidents.
The potential for clean electricity production from ocean winds is almost unlimited. Building large-scale power plants at sea is a huge challenge, and it all starts at the port. The foundations for the wind turbines consist of 2 pieces: 10-story high metal tubes called monopiles, and yellow transition pieces, which are placed atop of them. Loading the installation vessel with this giant cargo requires precision and experience. Once at the site, the ship lowers its legs until it stands firm on the sea floor. The crane lifts the monopile into place before driving it deep into the seabed. The transition piece is placed on top of the monopile. It will provide a solid base for the turbine and serves as platform for technicians arriving by boat. With the foundations in place, the ship returns to port to pick up the wind turbine components. State-of-the-art installation vessels can load 4 complete 8-megawatt class wind turbines. That's 4 towers, 12 rotor blades, and 4 nacelles, which have been pre-assembled on land to reduce time spent at sea. Under ideal conditions, it will take just 24 hours to load all 4 turbines onto the ship. Specially designed fixtures and sea fastenings ensure they arrive safely at the site. As wind turbines develop, and especially grow in size, equipment related to all aspects of them also need to be developed. That's why Siemens Gamesa developed a lifting yoke with automatic connections. The crew can move large components like this tower via remote control from the safety of the ship's deck. Once the tower is in place, it's time to install the turbine housing, known as a rotor hub and nacelle. Each nacelle hosts the generator and all the other electrical components which will transform the kinetic energy in the wind into electricity. Even in high winds, the technicians on deck are in complete control of the components at all times. They can install the nacelle safely in less than 2 hours. Now it's time for the 3 rotor blades. These giants measure 81 meters long each, or roughly the same size as the wingspan of an Airbus A380, the world's largest passenger jet. As the enormous blade draws level with the nacelle, the technicians make the last adjustments. The blade docks smoothly and safely. With technicians working almost exclusively from the deck of the ship, installation can continue at wind speeds of up to 12 meters per second, which compares to a wind speed of 6 on the Beaufort scale. With this, a new offshore wind turbine can be installed in a single day. Over the following weeks, technicians connect the cables and thoroughly test all the turbines in the wind power plant. Once the power plant goes into operation, the wind turbines feed into a single offshore substation. The substation transports the energy to shore via high voltage cables, from where it supplies the onshore grid. Each 8-megawatt Siemens Gamesa offshore wind turbine can supply more than 8,000 average European households with clean, renewable energy.
Be good to see some data come from it and make sure we're ready to roll.
James Wiley's company, Geodynamics, is one of the first companies to work on the offshore wind projects in North Carolina.
We are the first people to go out and evaluate a potential site to see if it's feasible for consideration as an offshore wind site.
I've got some cool graphs and such I could show you.
It's one of the first steps in a very long process. Wiley says the surveying part is pretty easy, but getting hundreds of these wind turbines out to sea will require lots of manpower.
So it's going to require a supply chain to be developed across the board, from some of the obvious things like hard manufacturing and large scale industry, but also sort of a soft supply chain where we're looking into technical jobs that are based on everything from academic research to highly skilled and scientific positions.
That means some of these coastal communities will have to develop new training programs to create a strong local talent pipeline. It will require collaborations at the university and community college level, but also at the middle and high school level.
I think it is important to remember that, if these installations are going to start really moving forward in 7 or 8 years, that a lot of the folks that are going to be doing that work are currently in middle school. And so we've got some work to do at the middle school and high school curriculum levels as well to kind of start getting people acclimated and kind of headed down a path towards these kinds of jobs.
Steve Calland is the executive director of the North Carolina Clean Energy Technology Center. He says it's crucial that North Carolina has the workforce in place to support this multi-billion-dollar industry.
So it means that we're going to be making parts and assembling pieces that are going to be creating jobs in an area of the state down at the coast where we have, not had a lot of jobs historically, and so there's a lot of opportunity to kind of grow the overall employment sector in the state while creating these manufacturing jobs.
I have like a single boat out there.
One of these communities where there may be a big opportunity is Morehead City, where Geodynamics is based.
Like the little crosshair
James
thing.
Wiley says he looks forward to not only the long-term economic impact of coastal wind, but also the short-term impact.
I think it's an opportunity to build the sort of STEM career path for a lot of people in this area in what's been traditionally, more rural area, less focused on sort of these high-paying job opportunities related to engineering and technology as they sort of move into our communities.
And while offshore wind is expected to bring big dollars to North Carolina, there are concerns about how it may impact coastal tourism and marine life. That's why Wiley and his company are working to collect data to figure out the best spots in the ocean to put these turbines, so that North Carolina can create jobs and economic impact while also protecting its valuable assets.